Alrighty. All right, welcome everyone to the ASPRS Heartland Region Text Talk Series. This is our first of 2019. We're going to try to make this a monthly thing, cover a variety of subject matters across the industries here, from LiDAR, GIS, photogrammetry survey, some industry trends, try to talk about some new cool technology, any of the other related topics to that. Our first one here, I guess to start with some housekeeping stuff. We just recently had our elections and are transitioning to our new group here for the 2019 to 2020 year. Paul's now old news as he's past president, stepping up as president. And then with our elections, we've got John Tolini, Patrick Bailey, Ethan's carrying over for secretary, as well as our new region directors there. Just something other quickly to announce, we are funding students for PCORA and fall 2019, so if you guys have any recommendations, know anybody that might be interested in that, we can definitely help them out financially and get them more involved with the ASPRS and then the industry as a whole. So I guess on to the presentation here. I guess I should mention first, I think there's a question box on the right if you guys want to ask any questions there. I will be handling those, and we'll also be taking questions at the end. Alrighty, so our presenter today is Will Knight. He's in the Kansas City office here, works for Wilson & Company. He has 20 years of experience in land surveying, covering a variety of topics there. He began in the U.S. Army as a topographic surveyor. He's been a CAD draftsman, instrument operator, a survey field crew chief, and with Wilson & Companies, he is the Midwest survey manager. He's performed a variety of survey tasks, including ALTAs, boundary, geodetic, topographic surveying, been involved in aerial mapping for transportation design, as well as bathymetric and bridge surveys. So I guess with that, I'll turn it over to Will.
Thanks, Whit. Just a quick note about Wilson & Company and who we are. We were founded in 1932. Wilson & Company is an engineering, architecture, survey, mapping, environmental, and planning firm. We employ staff in 16 offices in 10 states. Our staff of more than 400 professionals include civil, mechanical, electrical, and structural engineers, architects, planners, biologists, surveyors, mappers, GIS specialists, construction managers, and inspectors. We provide services to federal and municipal governments, public transportation agencies, railroad companies, industrial and commercial corporations, private developers, institutional, primary, and secondary education, and energy companies. The cornerstone of our success is higher relationships, which is driven by 5 tenets in discipline, intensity, collaboration, shared ownership, and solutions. So before we start any meeting, we'd like to take a couple minutes to recognize safety hazards and a couple ways to potentially do our job a little bit safer. Wherever you may be in the interwebs, something to think about is, what the method of ingress and egress from your office is in case of a fire or inclement weather, and to be aware of your surroundings. Let's get going. So this is just kind of a Survey 101. I put this together a while back, and there's a lot of different facets to what we do. A lot that maybe some people might not recognize. As Whit mentioned, we'll have a Q&A session at the end, so we'll try to address these as they come in. But if there's anything that you'd like more information on, we can ask at the end of the presentation, or feel free to email me. Today's objectives, we're going to kind of go on a high-level overview of surveying. I think it's important to mention the equipment that, especially here in the United States, that was used past and present. Types of surveying, a little bit into LiDAR mapping. I noticed that the industry is changing as a whole, and it seems like more and more we're getting exposure to LiDAR and integrating that into our products. Then we'll have a section where we discuss kind of the best practices, how you scope a survey project and collaborate with surveyors, And to close, we'll have a little Q&A session. So, equipment of yesterday, I think it's very important to understand to how we got here today. So, in the colonial period and throughout the 19th century, most American surveyors measured distances with chains like you see on the left. The favored form was the Gunter chain, which is shown here, and that was introduced by the English mathematician Edmund Gunter in 1620. The chain has 100 links and measures 66 feet overall. When the original GLO surveyors measured the United States, these chains, you would have 80 chains, and that would equal 5,280 feet. So 10 square chains would equal an acre. The Government Land Office oversaw the original subdivision in the United States to facilitate the sale of lands due to the westward expansion. This chain was instrumental in this effort, measuring square miles into sections, townships, and ranges. The evolution of that chain was the steel tape. And although it seems relatively simple, these steel tapes were calibrated and measured against a standard for consistent distance measurement. Just to note that those are not available at Home Depot. One other item of great importance that we need to discuss is the solar compass. So the solar compass is a precision instrument that was made of brass with a solar attachment that allowed the surveyor to determine the true north direction by reference to the sun rather than reference to the magnetic North Pole. It allows surveyors to locate true north through viewing the sun and other astronomical observations. It was not influenced by magnetism from iron ore in the ground. The United States government required land surveys to be done by solar compass, as in many cases the cost to accurately survey lands with heavy mineral deposits that interfere with normal instrumentation would exceed the value of that land. So moving ahead a little bit to today's equipment. Today we operate using things like the robotic total station, which replaced the solar compass. The robot is an electronic and optical instrument that's used for surveying. It's an electronic transit anti-light integrated with an electronic distance measurement tool, an EDM, to measure both vertical and horizontal angles and the slope distance from the instrument to a particular point. This is coupled with an onboard computer to collect data and perform triangulation calculations. The robotic portion, or servo-driven portion, allows the operator to control the instrument from a distance via remote control. This eliminates the need for an assistant staff member, as the operator holds a prism reflector and controls the total station from an observed point. It's really fascinating where these have come from and how great some of these advances have been in our technology. While the steel tape was the evolution of the chain, the EDM, the electronic distance measurement tool, was something that took that even further. The EDM is laser driven, and when it originally came out in the 1970s, it was used to measure great distances that would have taken weeks and months to obtain. And also, we routinely use GPS. Now, GPS is kind of a catch-all term, but its origins are complete within the United States. So GPS system is a satellite-based radio navigation system owned by the United States government and operated by the United States Air Force. It is a global navigation satellite system that provides geolocation and time information to a GPS receiver anywhere on or near the Earth where there's an unobstructed line of sight to 4 or more GPS satellites. GPS was launched by the United States Department of Defense in 1973 for use by the United States military and became fully operational in 1995. It was allowed for civilian use in the 1980s. So while GPS is something that is that has started with the United States. There are also other satellites and other satellite constellations from participating countries. China has their flavor, which is Beidou. It's a regional system currently limited to Asia and the West Pacific. They plan to have global coverage by 2020. Galileo is a system that was developed by the European Union, and it began operation in 2016. GLONASS, which is Russia's global navigation system, it is fully operational worldwide. IRNSS is one that was created and developed by India. And finally, QZSS is a regional navigation system in development that would be receivable within Japan. Modern GPS receivers that we purchased are starting to integrate these other satellites into their wheelhouse. And what's so great about this is instead of only relying on 4 satellites, now we routinely see upwards of 30 to 36 satellites at any given time from varying constellations. This allows us to raise the level of accuracy and also reduce the time needed to collect positional information. I think it's also important to recognize in today's equipment is that the advantages of SUAS. So in 2016, the Federal Aviation Administration announced regulations for commercial operations of small UAS craft, or SUAS, those weighing between a half pound and 55 pounds, including the payload. The rules which exclude hobbyists require the presence of all operations by a licensed remote pilot in command. Commercial operation is restricted to daylight, line of sight, under 100 miles per hour, under 400 feet, and Class G airspace only. It may not fly over people or be operated from a moving vehicle. These are outfitted with high megapixel cameras for small photogrammetric missions. And then also in today's wheelhouse, we're going to discuss LiDAR a little bit. Laser scanning and what it can do and where it's from, how we collect point clouds, and the applications of such. So terrestrial, which is either tripod-based or mobile, and then aerial platforms via either fixed wing or rotary. So now we're going to talk a little bit about maybe some of the more common types of surveys and mapping. And I don't know, when I was putting this together, I thought, holy cow, there's so many different varieties of surveying. So I'm going to paraphrase here and do my best impersonation of Bubba Blue from Forrest Gump. Anyways, like I was saying, surveying is the fruit of the engineering seed. You can map it, stake it, plat it, fly it. There's bathymetric surveying, aerial mapping, topographic surveys, boundary surveys, easement surveys, legal descriptions. There's monumentation, horizontal and vertical control surveys, bridge monitoring, UAV surveys, drainage surveys, roadway surveys, transmission and distribution line surveys, rail and hydraulic surveys, ALTA surveys, and subdivisions. That's about it. Let's talk a little bit about kind of the backbone and framework of horizontal and vertical control. To have a workable map that's relative unto itself, the governing location and position has to be correct and accurate. This is where your project is going to be located on the earth, and this needs to be known to clearly be able to make a comprehensive map later on. It has 2 components, one of horizontal location and one of vertical location. Horizontal datums may be something as simple as local site control, or starting your coordinates at an X of 10,000, a Y of 10,000, and a Z or vertical value of 100. And that's fine as long as the project doesn't need to be relative to anything else. If it's into itself, that's just fine. However, most surveying mapping deliverables and products now are in grid coordinates or state plane relative to NAT 83. For vertical datums, sometimes you have legacy systems that are within a city, a county, a state. They may have something that they've relied on and created plans from over time. However, typically, most vertical components of these projects are relative to NAVD 88, which is the most current, or even in a legacy system, NGVD 29. You see the 29 system on a lot of city projects where they may have created plans during the turn of the century, but still want to have their new improvements be relative to what was originally created. Now, the NGS is the governing body of these publicly available control values. So horizontal and vertical control, or NAT 83 and NAVD 88, is governed by the NGS. The NGS and this website is absolutely fantastic if you're in any of the geospatial realms. I absolutely love their tools, and I think they're on the cutting edge of what's out there. They seem to be truly progressive. At its core, where we derive horizontal and vertical control is the NGS data sheet. The NGS data sheet is a text file which contains data for a survey control station, either vertical or horizontal, and to what fidelity it is. Data sheets for horizontal control precise latitude and longitude. Data sheets for vertical control stations show precise orthometric heights. Other data may include your geoid height, your state plane coordinates, and a description of how to reach the mark and other recovery information. With the evolution of GPS surveying and CORS networks, these monuments are becoming less and less relied upon, but they're still out there. And the NGS tool site, their toolkit, actually has a thing that you can go on there and locate them within the nearest distance to you. Okay, let's move a little bit into boundary surveying. So the purpose of the boundary survey is to reestablish or recover the property corners of a piece of property and accurately define the limits. Property lines are identified on boundary surveys using a system called meets and bounds. This is relative to record distances, direction, and adjoining servitudes to the property. The different types of boundary surveys here that we have listed are an ALTA survey, a right-of-way survey, an easement, and a subdivision. So the American Land Title Association came out a while ago and decided to find a way to help ensure the title company and or lender on a piece of property. And an ALTA survey goes through and it will provide a running title report of what the property has been, any servitudes, easements, or anything like that that would be found or recorded on a piece of ground. We like to call it the Cadillac of surveys because they're very complex, can be expensive, but you're going to get the absolute most data that you can from it. We had mentioned, of course, that there's boundary lines, but the location of any improvements, and when they say improvements, that means something with a foundation or something that's more permanent in nature. And then identification of easements, access rights such as water, gas utilities, telephone, railways, and other utilities, and also to kind of give the recipient of the ALTA survey some confidence in where their boundary is. Any encroachments or gaps or overlaps in the title work will be revealed on the ALTA survey. Additional optional requirements are known as the Table A, and that can include things as building setback lines, height of structures that are on the site, areas of disturbance, if there's spoil piles from excavation. These truly can be the most illustrative survey that we can create. Right-of-way surveys is where data is gathered on existing property, existing right-of-ways, typically associated with a roadway, railway, corridor-style project, and in areas where unwritten rights may exist. These can be used for appraisal or acquisition purposes. So if you have Google Fiber coming through your neighborhood or something, and they want to acquire a 5-foot easement, potentially you could say that's a right-of-way survey, or something to show where the public's interest may lie. Now, one thing to remember about right-of-way maps is they don't plat the remainder of a piece of property. So an easement survey, and the legal definition of an easement, is the right to cross or otherwise use someone else's land for a specified purpose. Typical uses for easements are utilities, access, which would be ingress, egress, and other encumbrance that the real property may benefit from later on. Classifications of easements can be on the surface, like a roadway or an access drive, subsurface, as in you bury utility, and overhead, like a transmission line. And finally, in boundary surveys, we have subdivisions. A subdivision is simply taking a larger property and breaking that into usable areas for residences, commercial land, larger utility facilities, and to dedicate roadways or corridors. It can be, as we state here, as simple as mom and dad own 40 acres and we want to cut 5 acres off for us, or complex, maybe in a residential subdivision where you have hundreds of lots. All right, moving into something that I really like is topography. So topographic surveys. Topographic surveying is defining the land, the terrain, the features that may be out there. So a topographic map that we would create is characterized by large-scale detail and representation of relief, usually by contour lines. Topographic maps show both natural and man-made features. They also can show planimetric features, and some of the data collection methods that we use are conventional, such as GPS or robotic total station, aerial mapping, and LiDAR. And then the data uses are for engineering design, contour generation, a DTM. This one's pretty good here. This is interesting. So bathymetric surveying is the underwater equivalent to topographic mapping. The data used to make bathymetric maps comes from an echo sounder or sonar mounted beneath or over the side of a boat, which will ping a beam, which pings a beam of sound down at the water basin bottom. The amount of time it takes for the sound to travel through the water, bounce off the bottom of the body of water, and return to the sounder informs the equipment of the distance to the water basin's floor. If you'll look there on the right, this is a photo actually taken last week in northwestern Missouri, and due to the flooding that's occurring along the Missouri River, this photo is 4 miles east of the Missouri River, to kind of show how much water is getting pushed through there. Then at the bottom left is a subsurface DTM, and it's particularly interesting because if you have a typical waterway, and with the amount of flood waters that get pushed through, you have what they call scour occurring underneath, which is really hard to determine in flood waters unless you have some way to measure it. So let's jump a little bit into LiDAR here. So LiDAR is light detection and ranging. The methods, and I think I've mentioned this before, is the methods we use are fixed wing, rotary, and then terrestrial versions of mobile and static. There's advantages to each. So the basic principle of LiDAR data collection is a combination of three things. That's laser ranging, GPS, and an IMU. LiDAR is an active sensor and can be acquired at night if you don't mind your point cloud being colored as in true color or using imagery to show to illustrate what it's actually doing. For fixed wing LiDAR, these are large areas. This is an airplane mounted sensor. This is wide area mapping, floodplains, counties, some forestry applications, larger landfills and quarries, and able to achieve 1 and 2 foot contour interval projects. This is really what you want if you need to survey a very large piece of ground quickly, this is the only way to go. Rotary wing is a little more focused on something that's a corridor. It has a little more narrow footprint, but the accuracy starts to go up. So these are excellent for uses in corridor mapping scenarios like a roadway for the DOT or transmission corridors. Some pipeline projects have been mapped using rotary wing LiDAR. This is a high point density for smaller feature identification, and it's amazing how far this technology has come in just the past 10 years. And then moving down a little bit closer is the mobile data collection. Mobile LiDAR is very good where you don't need like a perpendicular line to the ground. You need to see what it's doing horizontally. This will acquire several points per square foot. It's a very dense point cloud. This is accompanied with a camera or imaging sensor for a colorized point cloud. We control the point clouds with targets that are located using conventional survey methods, so a robotic total station or GPS. This gives you greater detail. We see most applications on this in transportation projects where paving depth is important, or areas that are going to be obstructed later on. This is a great way to do it. And then finally down to the tripod-based LiDAR. These are going to be your smaller areas. One thing to note about static LiDAR that we have found advantageous to us is the ability to measure areas which may be unsafe for surveyors to access or difficult to reach areas. If you have radiation concerns or confined space concerns, if you have traffic to worry about, this can be an excellent tool to map those areas and collect that information without putting your people into harm's way. Some of the typical applications that we see are, of course, civil engineering. That's our bread and butter. As-built surveys, moving into architecture and BIM seems to be very popular now. Archaeology and cultural heritage documentation is really great because you don't have to physically occupy the points that you're trying to collect. It's very good in mining. We really like it for bridges. Our structural guys really are impressed with the level of detail that we're able to collect and how safe it is. Roadway intersections, and then, like we said, unsafe to access areas. We've found that by using a tripod-based approach, we can reduce the amount of time that we have people on site. We can reduce the amount of traffic control. It's also less of a disruption to the general public when we're doing this. And then kind of round this out, construction surveys. So construction staking or typical applications that we have here is this provides a builder with planned grades and position of new improvements to be made to the real property. We may mark this with stakes, hubs, posts, nail, and color-coded flagging to guide construction crews on how much earth to remove, add, and where to build. We can see here, this is one of our crews down in Texas measuring a pipeline to make sure that it's being put in the right location, and also to locate critical welds on the pipeline itself. Post-construction, routinely we'll get asked to perform an as-built survey. An as-built survey is where surveyors collect data about the improvements made, and then the information that is gathered is compared to what was designed for accuracy. You know, sometimes contractors don't always build what they said they would. An as-built survey can serve as a record of construction. So now kind of moving into the next section of scoping a project for surveying, there's some critical elements that I think that everyone should probably be aware of. The largest considerations is, what's your budget? What accuracy are we trying to achieve? And what's your schedule that you'd like this done in? You know, sometimes we don't always have the benefit of the doubt in knowing all this criteria, but this is something that you probably want to discuss with the consultant before you start to scope your project. You know, some considerations to look at. Is there existing control on site? Is there some legacy system that we would need to acquiesce to? Is this part of a larger project? And finally, what's the purpose? Why are we building what we're building? Why are we surveying this? So, in summary, for kind of scoping, identify your purpose, find the type of survey needed, to clearly define the limits of what you want measured, specify your control parameters and accuracies, identify any critical points that are needed, and then finally, what is the delivery method going to be? For plan practice, you want to use published survey control and record data. You also want to look at the constructability of what's going to be made. You will need a way of checking it, as built, and then provide electronic files to the consultant to help you determine what to do. Finally, you know, there's many tools and combinations to choose from. Collaborating is key with your surveyor or engineering firm to receiving the best survey for the lowest cost. The project size, layout, and required accuracies help determine the type of survey needed. All right, guys, I try to keep it short and sweet. Do you have any questions for me? Whit, do you have any over there?
Yeah, Paul, is there anything that came up on the text box there?
I'm not seeing anything in the chat, but yeah, feel free to just speak up. I can unmute you, or you can unmute yourself and ask Will any questions you might have. Thanks for doing that, Will.
Yeah, so thanks, Will. You know, I think a lot of us working with LiDAR and a lot of the derivative products there, you know, the survey aspects is something that's real easy to get lost there, but it's still the basis, you know, for the foreseeable future. It's still the basis for everything we do there, and setting the data locations with control checkpoints. You know, something we always overlook, at least in my world, you know, I always assume survey is, again, the kind of the control checkpoints or any type of topo information. But it's always really cool to see how important the legal side is with a lot of the boundary surveys and stuff like that. So again, if no one has any questions, I think we'll wrap it up here. Thanks again, Will. And we'll be. Okay, I think we have some questions.
Yeah.
I had a question. This is Scott Dodson with KBM Geospatial. The survey accuracies you were showing on your slides, are those horizontal or vertical accuracies you're quoting?
You know, I think that that's a good point. You probably want to define both, you know, horizontally and vertically. How tight, quote unquote, what do you need your data to be? You know, if you're looking at like kind of we were discussing large scale mapping, you know, square miles, accuracy within a foot vertically is probably acceptable, and then within a foot or so horizontally. And then as you kind of, you know, as you reduce the scale or you reduce the size of the site, you know, you want to start looking at higher levels of accuracy. Case in point, a couple of weeks ago, we were asked to monitor a bridge for a Class 1 railroad that they thought was sinking. And we had actually set 4 prisms over each pier on this railroad bridge and had 4 robotic total stations measuring 1 second epochs to each one of the prisms as trains ran over it. They were looking for quarter-inch accuracy. Now I know that's a little funny, but that's from a structural person. That's pretty common. You know, and we were able to actually measure within a 32nd of an inch, which I thought was pretty phenomenal. It all depends on what your goal is to do with your survey, and then determine, you know, within what tolerance do I need to know which way this is moving or where it's located in the world. I hope that answered your question.
It did, thank you.
So we have a couple other questions in the chat. Someone asked, are you using UAVs much for surveying?
So UAVs are a very interesting thing right now. You know, I'm really encouraged with the direction it's going. You know, photogrammetry has been around for 100 years, but small-scale photogrammetry is really impressive. And I think, you know, the accuracy may not quite be there yet, but you know, we certainly deploy UAVs. Now, one thing that's worth discussing here is 99% of what you're seeing UAV emissions that are being done right now are using imagery or the sensor as a camera versus an actual laser firing LiDAR sensor. As far as a UAV platform is concerned. And a lot of that's been driven by the actual weight of a LiDAR unit. You know, they range from 50 pounds and down, and that kind of, you know, it's getting better. Just like anything with tech, it's getting faster and smaller, and it's starting to cost less. But with UAVs or drones, you know, you really want to be very careful about what you are going to use that information for. If it's for line of sight or visualization, if it's something for like a public meeting, hey, that can be just fine. Or if you're trying to generate, you know, like a contour map that's accurate within a half a foot, well, you may be okay with a UAV. But as far as something that is I know a lot of people throw this around, quote unquote, survey grade, only if it's really controlled or highly controlled and there's lots of targets on the ground and lots of ground truth points that have been measured accurately, can you say, yes, that LiDAR, or excuse me, that UAV or UAS survey is as accurate as what you're trying to achieve. One of the things that I've noticed personally with a UAV versus, say, a manned aircraft or a fixed wing or rotary wing is when you collect that imagery, the UAV is the point of diminishing returns of where it becomes more expensive to collect it on the ground with a UAV versus a manned aircraft. The sweet spot is right around 300 acres. Anything more than 300 acres, by all means, put somebody in an aircraft up there to collect the information. If it's smaller than that, you can probably get it with with some of the UAVs that are available now. However, it's going to take quite a while.
That makes sense. We have one more question about GPS units. Are they changing as more satellites become available?
They really are. You know, I mean, I know when I first got my start 20 years ago, we carried around Trimble 4000 series GPS units, which was a backpack with camcorder batteries in it and a radio link, and it was very heavy and cumbersome. And that was a time where if you had 6 satellites, you were really doing something. Now, you know, natural progression is everything is so much lighter. Everything is so much faster. And the integration of those other constellations or other GPS satellites has evolved so much. Now, I think maybe we're at a saturation point on GPS tech as far as that goes. There seems to be some small incremental developments as like infill, where if you are outside of the woods and you're collecting GPS signals where you can go into the woods and you lose your canopy and you lose your lock to those satellites, where an IMU is integrated into the GPS unit to kind of give you a trajectory through there till you pick up your signals again. You know, but there's not huge game-changing shifts in GPS technology. There's still some ways to use it and get into trouble. Like I said, you really don't want to get into the woods with it, but there's ways to mitigate that. And you know, I think you know, we're looking at right now the big change is with data collectors that are linked to your GPS receiver. You know, it used to be a glorified calculator was your data collector. And now we're seeing data collectors with Windows 10 and just as much power as the laptop that we're using today to present.
All right.
Do you have any other questions off the chat?
That's all I'm seeing so far. Yeah, thank you for fielding those questions and giving the presentation.
Absolutely, guys. If there's anything I can do to help, just feel free to reach out to Whit, and I'd be more than happy to guide some of you guys on your survey projects.
Awesome. Thanks, Will. And we'll have more information about the next Tech Talk out to you guys soon. I hope everybody has a great rest of the day. Talk soon. Bye-bye.